This part of the lesson is extension, meaning it will not show up on the power assignment, but it is good information and could show up on your portfolio and is useful for future classes. All right, there are types of inequalities called compound inequalities. Very fancy way of saying it's just more than one inequality at a time. And we join them together with two words, either the word and or the word or. The ors tend to be simpler because for that, you just include all the solutions to either inequality. Whereas for and, you need to be a little bit more careful because we want only the solutions that are shared between the two parts. So how do you graph them? Here's how you graph them. This is an or inequality, meaning we want to include everything. So I look at my first one, n greater than 4. That means I go to 4, open circle, arrow to the right. The second part of it, n less than 1, go to 1, open circle, arrow to the left. Because it's or, we include everything. This is the graph of the compound inequality. See, that wasn't so bad. So it's all the numbers that are to the left of 1 together with all the numbers that are to the right of 4. We're saying that if a number solves this or this, it counts as part of our solution. Now for the ands. I'm actually going to do this one in steps. So the first step I'm going to do in a different color. So let's start with the blue here. The first inequality is t greater than or equal to 0. So I'm going to go, let's say, just above my number line here. That means at 0, I want a filled-in circle that goes to the right. Right, so here's the first inequality. The second inequality, t less than 6. So at 6, open circle going to the left. The and means I want only the numbers that solve them both. So for example, 3 solves them both. It's in the overlapping section. 3 is greater than 0 and 3 is less than 6. But, for example, 8 doesn't solve them both. That's only a solution to one inequality because 8 is not less than 6. As far as graphing your solution, you take a look at where the overlap starts. So here it's just the 1. Here is where the overlap starts with a filled-in circle. Then we overlap for a while. The overlapping ends right here with an open circle, and I want to include the parts in between. Now, it's important to know the solution graph is only the red stuff. The blue is what we used to get the red stuff. So the numbers that make both of these true are just this overlapping section. So all the numbers from 0 to 6, including 0, but not including 6. Let's go again. You'll notice this one doesn't have either word, but when it's written this way, this means and. It's giving us essentially a left and a right end, and we're including only the parts in the middle. So think of it as x is greater than 3 and, excuse me, x is less than 7. We write it this way just because it's easier, it takes a little less time. When they're written like this, it's super easy to graph them. At 3, open circle. At 7, open circle, and you fill in between. The x is between the 3 and the 7, so your graph goes between the 3 and the 7. Next up, another or. So n less than or equal to 4, so at 4, closed circle to the left. Or n greater than or equal to 5, so at 5, closed circle and to the right. Don't make the ors complicated. Now for this next one, same thing. It's an or, so y less than 7, open circle at 7 to the left. Y greater than 1, open circle at 1 to the right. Ooh, this one actually looks a little different. Because if you think about it now, don't all the possible x values have graph above them? If you have an or graph, where the parts cross over each other, that just means your solution is really all real numbers. So if you have an or that overlaps, that means your solution is all real numbers, because every number is either less than 7 or greater than 1, or some of them are even both at the same time. So when an or overlaps, all real numbers, the whole number line gets filled in. And our last case here, an and. So I'm going to switch back to my blue here again. I'm looking just for the overlapping parts. So t greater than 3, so at 3, open circle to the right. T less than or equal to 2, so at 2, filled in circle to the left. And this is an and, so I want the overlap. Well, as I look at it, so in our previous example, we had our blue lines on top of each other. We don't have that this time. These two graphs never overlap. That just means this time, nothing goes on the graph in red. There is no solution here. When you have an and compound inequality with no overlap, that just means there are no shared solutions, and therefore the compound inequality has no solution.